Okay, because of currents and tides and waves, adding onto that, the plate tectonics driving active versus passive margins. So what is it we see? What landforms do we see as a result of all of this on our coasts? Well, again, landforms are dependent on the type of coastal margin, active versus passive. They vary dramatically in terms of topography and landforms because of so, as well as due to the motion of water, whether it's, again, currents, tides, waves. So the coasts vary dramatically in terms of topography and landforms. Some are rocky shores, some are sandy beaches, some are swamps, some are mountainous, etc. There's two major types of coastal morphology, so what it's shaped like, what it's looked like. One is dominated by erosion. So these are landforms that are created by material being taken away, typically active margins, where the landforms you see are due to material being broken down and taken away. The other coastal morphology is typified by deposition, typically passive margins, where material is being deposited. So erosional landforms, again, there's a lot more geologic activity, more typical of active margins. Depositional landforms are more typical at passive margins. So let's first look at erosional coasts, more indicative, not always, but just more indicative of active margins. They tend to occur on the leading edges of plates, kind of where a plate is crashing into one another or moving relative to one another, so right near a boundary. Typically, erosional coasts typically near active margins exhibit high relief, rugged topography, mountains, hills very close and or near to shore. It's really dominated by old exposed bedrock with really steep slopes, again, high elevations, rugged, mountainous, pretty near or adjacent to the shore. The rate of shoreline retreat, so how fast kind of weathering and erosion eats at the cliffs, is typically slow, because what you have on these erosional coasts, on these active margins, is typically rock. You've lifted up rock due to convergent boundary, and you have hard rock, and it's hard to break that material down. So the type of rock and its lithification are important factors to the rate of erosion. So if you have this hard old rock, it's hard to break through, so the shoreline retreating in most places is very slow. Some places it's fast. The west coasts of both North and South America are excellent examples of erosional coasts. Both are active margins near plate boundaries. So what are some erosional landforms that we might encounter on these erosional coasts? Things like wave-cut platforms, beaches, bays, natural bridges, headlands, sea stacks. And we'll go through and talk about some of these. But here is a typical view of an erosional coast. So you got cliffs right here. You have an arch right here, a little bay with a beach right here. Very typical of a erosional coast, typically near active margin. Not always, but typically. So what are some of these erosional landforms? So the first is a bay, as defined. It's a broad inlet of sea where the land curves kind of inward and directly connects to a larger main body of water, such as an ocean. So kind of this bending inward, and this is connected to the ocean. So it's being considered a bay, lovely looking bay, very rugged, mountainy terrain. Here's a different one. Again, kind of the bending inward, lovely little beach, calm waters connected to the ocean. And then we have wave-cut platforms. This is a narrow, flat area often found at the base of a sea cliff or along the shoreline, and usually is where you have a good amount of tidal range. So as the waves kind of cut in and hit these harder, more resistant rocks, they'll kind of eat away at the bottom of them. And as they do, the larger face will fall off, and then the cliff kind of just retreats and retreats and retreats. However, there's a part of that hard rock that is just not eaten away, that's underwater. That's the wave-cut platform. And during high tide or low tide, at low tide, that wave-cut platform could be exposed. So this is all the same rock. This is all the same rock, but as the high tide comes in and waves come in, it eats the bottom of this right here. and then it falls, the cliff falls off, retreats back, creating more wave-cut platform. Headlands, another erosional landform. This is a narrow piece of land that kind of projects out from a coastline, out into the sea, out into the ocean. So again, just something jetting out, hard rock, active margin, typically erosional coast, jetting out into the sea, into the ocean. Here's another headland, but it's connected. That's the deal. It's connected to the mainland, but it is something kind of jetting out a little bit. So we have a headland here. A natural bridge, kind of what it sounds like. So natural arches form where coastal cliffs or headlands are subject to weathering and erosion. And these kind of go hand in hand with sea stacks. Sea stacks are steep columns of rocks in the sea near coast, but they're separated from the main shoreline or headland. So what we have here, this would be a natural bridge. So, because there's an arch to it. This would be a sea stack because it's no longer connected. At one point, it looks like this was all one headland, and then kind of weathering and erosion kind of made its way through, creating this arch. Now we have a natural bridge, and weathering and erosion kind of separated this piece off, creating a sea stack. Now, probably at some point in the future, this material looks like it's eventually going to fall into the ocean. I wouldn't walk out here if I were you, but this material looks like it will fall off, separating this bigger chunk, and now this big chunk would be considered a sea stack. Let me give you another part of the super secret code. So whatever your answer is so far, I want you to subtract from that answer the 18. So take whatever your answer minus 18. All right, you got me? So take whatever your answer is so far minus 18. All right, you got me so far? This is all mathematical. All right, so what we're going to do here is let's go ahead and take a pause. So we talked about erosional coasts, more typical at active boundaries and some of the active margins, near plate boundaries, and some of the landforms we see there. So we'll pause because when we come back, we'll talk about the opposite of that, depositional coasts, more typical near passive margins away from plate boundaries. So we'll pause here. I'll see you back in just a second.